Hi, everybody.
Hey, welcome back, Brian.
Welcome back, Aaron. We're all back. How are you guys doing? We're doing well.
I'm Aaron Steele with Microsoft Services.
I'm Brian Ricks with Brightcom Computers.
We're coming back and we're going to talk high availability, and then we're going to take another little break, and Brian will come back and talk disaster recovery.
That's right, and then we'll demo both, and you're going to just be excited.
Oh, it's
gonna
exciting.
Be awesome.
It's exciting.
That's right.
From a high availability point of view in Lync Server 2013, we're really going to talk about, in general, four things. Lync Server high availability, how you configure it, how you plan for load balancing, and how you design for load balancing. What we think about in high availability in Lync Server might not include load balancing, but you really have to take load balancing and hardware load balancers potentially into account when you're talking about high availability. In the first section of this module, we're going to talk about what our options are and how we enable resilience and high availability and what that really means. We're going to talk about the front-end pool architecture, the back-end server high availability options we have, how you can implement file sharing high availability, and finally what persistent chat high availability looks like, to bring it back to our persistent chat session from the morning.
Woohoo!
So when we're talking about this, we really have to first define high availability versus disaster recovery, or high availability versus resiliency. Resiliency is the idea that you can have a manual disaster recovery process used to recover from a complete site failure. That is disaster recovery. High availability, on the other hand, is really a service or system that's designed such that it is available to all users continuously, with only potentially for minimal scheduled or unscheduled maintenance. Lync 2013 can implement both of these features for the majority of the user modalities, right? So resiliency really does make high availability possible, right? Because if you haven't put in place the systems to allow you to fail to a second site in case of a disaster, then you can't ever get to a point where you're actually making the services highly available.
Right. Otherwise, you're stating something to the effect that we're highly available as long as there's no major disaster. Well,
Yep.
What kind of HA is that? Right.
Yeah.
And that's really a 2013 newity.
Yep. Yeah. We had, in 2010, we definitely had voice features that were highly available, and we provided voice resilience across those sites. In 2013, we do a lot more work to provide for resilience of the majority of the modalities and sets. The Lync front-end pool architecture is really a new distributed systems architecture. That is, the back-end database is no longer the real-time data store. And what we mean by the real-time data store is your presence data is no longer pushed persistently or no longer tasked by the SQL backend to keep that up to date. It's now the responsibility of the front end to keep those things up to date. User information, as we said before, is actually in fact kept up to date on up to three front ends, and a copy is pushed to the back end in case of a problem.
Right. So if all three of your front ends blow up, there is a data copy that's relatively current.
Yep.
Yeah.
Data distribution is automatic and completely handled behind the systems. As we say, there's really nothing you as an administrator can do to interact with or configure that. It just happens. If you've got 10 or 12 front ends in a pool, your users are going to be split effectively evenly across all of those 10 or 12 servers, with each user and their data existing on 3 of those, and then a copy on the back end.
Right. And so in theory, if you ever took down in a distributed model like that 3 servers, there is the potential you took down a user if all of his data was on all of those 3 servers.
Yep.
And there's ways to figure that out. But yes, they're generally figuring out, knowing what you can and can't do, how many servers you can and can't take down. Generally, no more than 2 ever will guarantee
that your users won't go down.
Right.
Yep. If you've got a large system, you can be pretty well guaranteed that taking 2 down won't negatively impact all your users or any of your users.
Right.
So, and that's why we get to this recommendation of at least 3 servers in a pool, even for much smaller sized organizations. It really comes to that those are the thresholds, and it's necessary to maintain pool functionality.
Right.
So, anything you wanted to?
Yeah, it is. It's one of those, I want to say evil necessities, because but the concept is we went from 2 as a minimal requirement, and technically we still are 2 for HA within 2013 from 2010 to 13. However, for functionality to be fully what you'd expect it to be, where SQL backend can be lost and things just kind of hum along.
For a period of time,
for a period
at
of
least.
time, for 30 minutes or so, you're
Yep.
going to need to have that HA world. And what that means to you is if you did have 3, that you can have a SQL outage by rebooting packaging. You can have a server single booted, and users are just up. So that's where we get our uptime and our HA.
Yep.
That's not going to happen if you're less than 3. So.
Most definitely. When we talk about backend server high availability in Lync Server 2013, really what we're talking about is you're deploying 2 backend SQL servers for each pool, and you're configuring synchronous SQL mirroring between those. With the addition of a witness, that will give you a recovery time of less than or equal to about 5 minutes.
Yeah, and typically we see that much less. Yeah, it's
Agreed.
very quick.
Agreed. So in the architecture here,
And where'd the cluster go? We were a SQL cluster in 2010.
we definitely were, and if you're migrating from a 2010 environment, and you want to continue using SQL clusters in your 2013, you're able to do that. It is supported during the migration scenario, and to continue using that in 2013. However, it is definitely recommended that you implement SQL mirroring, as that is the place that the tool and the server platform is going.
I'll also say SQL mirroring is much quicker than a cluster is. The cluster's got to stop and start services and things have to kick back up when you have a failure in totality. Mirroring's almost instant. And when we say the witness 5 minutes, I'm not sure where that number comes from. In my experience, it's been under 30 seconds. Things are just flipped and done. It's a polling process, so I get if you hit the very end of the poll, just happened to be when you went down and you just were successful, then perhaps, but it's fast.
Most definitely. And the user experience in that case really does, though, depend on that witness. If you don't have that witness server here monitoring your SQL server, you're definitely going to be in a situation where if your primary goes down, though the data is replicated over here to your mirror, nothing's going to notice that server is down, and you're going to have to invoke some management shell commands to tell this pool that its data is now on this other server.
Right.
Whereas if you've got the witness and it's configured into the Lync topology, the witness can inform the pool, hey, that primary one is down, you should start using this one, and you won't have to invoke those changes and those failovers
and within
yourself.
SQL, the actual flip will happen automatically as well. So not only are we updating our Lync, but it's possible that the databases end up in a state of
Split.
Don't know who 2 are active on one, 6 are active on another, and nothing's working right, and we have to manually fix that. And the way that we avoid that is the witness again. So.
No, and that's the other thing to remember about these witnesses, is it's a per database relationship for that mirroring.
Now the other thing with the witness, and I don't believe we get much more into him beyond this, him, her, it, is that the witness is any SQL server that's not part of our topology. So if you already have a SQL somewhere else, he can become a witness, and he's just monitoring and watching things as long as he has access.
But a big thing to remember about that is the two SQL servers in that mirrored relationship need to be of the same version.
Yes, and all 3, the witness and the 2, everybody's got to be the same. So if we're SQL 2012, we need SQL 2012.
Sure, but even beyond 2012, the witness can be an express.
Right. Oh yes, he can be.
The
express, but he must be the same version level.
Correct. The witness can be express, whereas these two, we need to have the same version.
Right. In lab, we see it set up all the time where a Windows box is put up, and we're saying Windows 7, Windows 8, whatever. SQL Express is loaded on there, and it works just fine.
Yep.
But do you want a Windows 7 laptop monitoring your SQL backend? Probably not. You probably want something a little bit more resilient and from a hardware perspective and monitored wise. But it is an important role. It's just a very simplistic role. It doesn't take much resources.
No, completely agreed. And if the witness goes down, it's not going to, in fact, affect your pool in any way, shape, or form during that time when it's down, as long as nothing happens.
Right.
So from a file sharing high availability perspective, we're really talking about DFS in this. We're really talking about the ability to have failover from one file server to another with the data stored in some location that is available on both. Delivered based on network size resiliency, right? 1 pair of files for all file shares in a site, or 1 pair per front-end pool. It's DFS, in this case, really should be DFSR, because we really are talking about best effort replication. The file share data, though important to Lync, isn't critical to the continued operation of any one user. Yes, they might tell you it's critical to their processes if they lose their data that they've uploaded during during a presentation or something, but they won't get signed out just because the file share goes down.
That's right. Well, what about people ask quite often, nobody has yet, I'm surprised, about some sort of NAS device for our file share witness, or file share. Right?
Technically, we support DFS and SAN file systems. We do not support NAS-based file systems.
And the Windows ACLIN has to be able to happen to the boxes. A lot of devices support that, but it's not supported from a Microsoft perspective.
Right, and it's Windows, it's ACLing of both the share and the file system underneath it that happen during the topology publish and the creation of that share.
And each time we republish the topology, it's constantly trying to make sure, is everything still working?
Yep, most definitely. For persistent chat, we break the model, just a little bit.
It's pretty big.
In that we have a different pool architecture, but again, we can have up to 8 servers in each persistent chat pool. 4 of those can be active at any time. We provide backend high availability between multiple SQL servers within a site across mirroring, and then we can do a stretched pool for disaster recovery where we use log shipping to get that data across to the other SQL server.
That's right. So we're not doing any of the automation and things of a backup service moving data for us.
Right.
Persistent chat is one of those things that's outside the scope of that.
Yep. But when you think about it, you really should recognize that you're using a different tool set. And I'm kind of surprised nobody in the chat window has asked about it, but on the backend server high availability, often people start asking, why don't we have always-on database support? And it is a question that we get asked fairly commonly. It really comes down to, it happened during the release cycles of the products. It was partially the release cycles of the products and partially that Microsoft decided, the Lync team decided that the always on, they couldn't guarantee was going to be there, and database mirroring, they knew would work in SQL 2012, SQL 2008 R2, SQL 2008, and those would all be supported systems that they could run on for your Lync server. If they'd chosen to go always on, they'd have required you to install a brand new SQL 2012 server every time, rather than being able to potentially reuse resources in your Lync 2013.
Yep.
So,
questions finally.
Sorry, just quickly jumping through here. So in terms of planning for load balancing, we're going to talk about this in a little. It really comes down to the fact that though we say Lync is a DNS load balance system and it's integrated into the client, and while that is completely true, because Lync also uses the Internet Explorer client that's on the browser and their interactions with those things, there is a need for hardware load balancing even in a pure DNS load balanced Lync server environment. So we have to talk about that and understand how we plan for load balancing of your infrastructure and plan for how the load balancing impacts coexistence during a migration.
Here's an interesting question, and we didn't address and talk about it, which is probably why they're asking, but it has to do with our previous slide, which is, okay, have 2 physically separate sites and have edge pools at the respective sites. Can I load balance them using DNS load balancing, and how it will affect particularly the AV edge communication?
No, you shouldn't use global load balancing. Each edge site across those edge sites, each edge site in a 2013 deployment is going to have a unique edge site name, and you wouldn't want to globally load balance across those 2 edge sites with the same DNS name.
Right.
Because
they're different names. First, from a topology, from a certificate. Yeah.
No, if you have a need for that site resilience, you need to monitor it with a third-party service. And if one of your edge sites goes down, you need to update some things in DNS and update your records to flip things to the other site as a primary ingress.
Here's one regarding SQL witnessing. Is there any strict one-to-one correspondence between witnesses and pairs of backend servers?
Yeah, you can't add the same server to be witnesses. I haven't seen. Can you add the same?
I haven't seen it as well.
Yeah, I don't think you can add the same server to be a witness for multiple sets of paired pools.
But that being said, I'm not a SQL expert.
Neither am I.
So there very well may be a way to do so, but
we haven't ever seen it for every deployment I've ever done in every lab and document I've ever seen, it says use a unique witness per SQL pair. SQL masters are welcome to dispute me on that. From a DNS and a hardware load balancing perspective, when we're talking about this in Lync, we really do have to recognize that there was a change that happened in 2010 that is still impactful in 2013, in that they put intelligence into the Lync client to understand multiple A records that were coming back to that client and be able to parse that data and understand which of those multiple records was the preferred one for that user to connect to.
Yeah, and I think that's key, is to understand that this is at the application layer. This has nothing to do with the network. If you, as a Windows client, were to go out and do a ping or
NSLookup.
NSLookup will show all the records.
Right.
If you were to do a ping, you would only get back one answer, and it would continue to alternate during the list when you were doing clearing pings and you cleared your cache the next time you went out and looked for one. That's really important because that's Windows. That's not Lync. Lync client, in fact, does an NS type lookup, gets back all the answers, and then intelligently figures out what to do with them.
Yeah.
So that's it. That's why it works. That's why we're not DNS round robining. We're not doing weird oddity things.
Right. It is really DNS load balancing, not DNS round robining.
Right.
That Lync client pulls back all those records, tries. Yeah, in a round robin, he tries the first one just like a round robin would, but he can actually intelligently figure out if that first one isn't the right one for that user to connect to.
Or if it doesn't respond, I know I can go to the next one. Whereas a typical TCP application would be like, well, I got back with my answer, it didn't respond. It doesn't know to keep trying.
Right.
We do. So.
With that being said, we still have these hardware load balancers, and you'll see hardware load balancers pictured on pretty much every Lync highly available deployment that you see. It's because we still have these web services, the simple URLs, the meet URLs, the internal administration URLs, Lync Discover. We have both internal and external needs for those HTTP type URLs that the client and the web browsers connect to provide different levels of user functionality.
And then from an HLB perspective, the requirements used to be, and this flows right into a question, requirements used to sit around, and specifically for mobility, around cookie persistence. The MCX application had to go to the exact same place every single time or it didn't work.
Yep.
The question is that still a requirement? And I would say, depends. If you're going to support older clients, yes, because that's still a requirement of the MCX app that's on there.
But if
you're all the brand new applications, the 2013 versions, then no, it's no longer required. We are completely stateless when it comes to the communication. We hit a place and it tells us where to go inside. It's all behind the scene magic. In
Lync 2013, the hardware load balancer requirement for mobility is about source persistence, source IP persistence, and that's the level of it that's required.
Right, it becomes very simplistic at that point.
But again, you do have to understand, as you're migrating, do you need that to continue to work for your 2010 clients?
Yeah, it definitely doesn't hurt to have it there, and it doesn't hurt anything to have a cookie persistent location, even if you don't need it, because if you're hitting the same, okay, what does it really matter? And the load balancer will say, hey, the server's down, so you're not going to go to a down server. So I mean, that's not a problem to leave it there. So I guess my canned response would be, if you've already got it and your load balancer supports it, why change it? It'll work just as fine with 2013 and it'll support 2010.
In terms of planning for your load balancing infrastructure components, really what you need to make sure is that you're keeping all those front ends in the pool operational, right? Yes, we understand that servers fail, you have to patch servers, you have to reboot servers, but you shouldn't put yourself in a position where for long periods of time, one server out of your pool is down and unavailable. If that's the case and that's going to be there for a long time, I would say a recommendation would be to remove it from the topology.
Right. Yeah. And maybe a better question is operationally why.
Yeah. Why is it down for so long? Why is it down
for so long? And if it is such a problem, why aren't we just replacing? I mean, who knows? But you really need to start asking these operational questions of what's going on here.
Agreed. You need to plan for and identify those cases that don't support DNS load balancing and understand on mitigation strategies for them, be it Exchange Unified Messaging or OCS 2007 Federated Partners or some other interaction you've got.
Right. Anything that requires some sort of backwards compatibility or external compatibility. And we fix a lot of things. Exchange UMing 2013 is not a problem anymore. Great. What if you're 2010? What if you're 07? What if you're doing OCS clients? What if you have external partners? What if PIC is so important that, as it is today, that it is always highly available? They're not DNS load balancing aware, so hardware load balancers are going to be required on the other side. It's those kind of drivers, and it gets back to our discussion on business understanding and requirements that will drive that discussion and decision. But if you don't need hardware load balancers, and this is not a knock to any HLB companies because I like them, but on the outside or in front of the pools, and if you can get away with just the web services and DNS load balancing, that's the way you want to do it.
Most definitely. It's simpler, it's cleaner, the environment will work the way it's designed.
Exactly, because the hardware load balancers, even think of it in an internal pool, even if I have an HLB and it sticks me to one server, if it's the wrong server, it's going to release me, tell me where to go anyway.
And you'll bypass it.
And you'll be bypassing it at the very end. So what's the point? I mean, it doesn't gain much. So anyway. Okay.
So, and then when you're talking about load balancing, you really need to plan for migrating. If you're implementing DNS load balancing on the internal side, you really do need to plan for migrating those previous versions of the servers and clients all the way up to Lync 2010. If you're still in a coexistence, you don't want to be in that position for a long time where you've got those things sticking around.
The question comes in, why are public IPs required on HLBs? Why is NATI not supported? Because.
Why? Right. Why questions of the Lync product group always scare me.
Yeah.
Because that's what they tested and what they decided to support, but from a technical point of view, it's what they've documented as the way it works.
Right, it's the way it works. That's how the yeah. I don't know, because
that's what the Lync product group has decided to document as the way it works. On the outside of the edge, if you're doing public, you need public IPs for hardware load balancers. So from a coexistence point of view, we've got this scenario where we could be migrating from OCS 2007 R2 up to Lync 2010 or Lync 2013. And you've got to figure out, where do you put the hardware load balancers for those R2 clients if they're still logging into Lync 2013 versus where do you put the DNS load balancing records for the Lync 2013 clients? Because the truth of it in this scenario is probably more accurately that these two hardware load, or this hardware load balancer for these Lync Server 2013 will be the record, the pool name will resolve to this hardware load balancer. But in fact, what's going to happen from these servers is they're going to resolve that pool name, same as everybody else, and then they're going to walk right around it to get to the server that's actually serving them out of the many servers in the pool.
Right. It just comes back to, we've done quite a few migrations from OCS 2007 R2 to 2010, not so much R2 to 2013, but not that you couldn't. But the issue was always, you had to have HLBs for the clients in 2007. Do you want to keep that implementation in order to keep the migration highly available, or do you care? During the migration, do you accept the risk that if there's an outage, the R2 people potentially, they may get the right box depending on what they resolved, they could, or they may not. Then that's a design question. Again, comes back to business requirements. So, but if you truly need HA to happen the entire time from current state, migration, in state, HLBs are going to be in the mix. And then it's not necessarily a bad thing to kind of roll them out towards the end either.
Right. As you've gotten these R2 clients out of your environment and decommissioned, you can and replaced with 2010 and 2013 clients that understand high DNS load balancing, you can actually move that record off of this hardware load balancer and just let it resolve to all these addresses and not the hardware load balancer anymore.
Oh yeah, the demigration of HLB is very simple. Just don't use it anymore.
Yep.
Change DNS. So.
Change DNS. So let's see. Designing load balancing.
Woohoo!
This really gets into what records are going to be required and what things you get into. We're going to talk about what it takes to actually implement DNS load balancing, what requirements there are, how you implement hardware load balancing, what those requirements are, how you would design those servers and services for load balancing, and then we give you some guidelines for using DNS load balancing for front-end pools, and then finally designing a coexistence strategy.
Okay.
So when you're designing DNS load balancing, we've talked about it before. You've got this other hardware load balancer out here, even in a DNS load balancing world, that's still handling all your HTTP traffic, right?
All right, your web traffic, yep.
In DNS, you have these two records for the servers, for each server. Two records for each server. There's van-feo1.8atom.com. But you also see that we've got this record here called pool.8atom.com. In fact, what happens is when your client goes out and requests from DNS the record for pool.8atom.com, it gets back both the 10.10.0.20 and the 10.10.0.30. It picks one of those at random and sends that request off to the front end.
Right.
Whichever front end replies, it has knowledge of which of itself and its neighbors is the preferred one for that user and in what order.
Right. The communication, and I guess the clarification, I don't know why we don't put it on the slide, is that pool has two A records. That's how we know that pool exists twice, is because...
Yeah, no, it says that.
It doesn't say it like you would expect it to say it.
Pool and all A records for pool, 1020 and 1030.
But that doesn't specify up in the picture. I'm telling you, it should be there.
I know.
The picture should show it. All right. Well, anyway, for me, I was saying it's not clear. I think from a clarity perspective, you have the server name individually with its IP, and then you have the server or the pool name with that same IP. So two records for every single one.
Yeah.
And they're A records that we're putting in there.
Right. We query for the SRV record. We may, in fact, query for Lync Discover, depending on the version of the client that's in use. And you'll end up returning the pool name as your target.
Right.
And that pool name resolves to multiple A records.
Assuming you've added them.
Assuming you've added them.
It is a manual process. Nothing's automated here, so.
Oh, come on. They haven't fixed it all for us, so it's automated?
We also say, and I don't know how I don't believe we talk about it. So from one of the uniquenesses of setting up DNSLB when we're in the topology builder and we're designing our web services, there's the option to uncheck the box to put in your own name for the
web services. Yeah.
And so if you put in the internal name, that's where we're doing is DNS, because we need two different names. We need the pool name. The pool name is what things are going to go to resolve the pool. But we're going to need a web service name that we're going to hardware load balance. And that's got to be separate. In hardware load balancing, that's not the case because we're all going to the same HLB regardless.
Right, right.
So that's what that's for.
That's exactly. When you've implemented DNS load balancing, you need to have this web traffic going to the hardware load balancer over here, and that is a different name than on this 10.10.099 than the IP addresses and names that go over to the pool.
Right.
A quick question that some people ask is, can you use DNS load balancing for a server running standard edition? And the answer is simply no.
Well, there is no...
There's a single server in that pool.
For everything. That's also why you can't uncheck the box to change the server name from a web service perspective on an SE, because it's all going to one location.
Right. So. It is, it's technically that you could put multiple records in there, but it's not going to do you any good because there's only one server providing that service.
That's right.
So from a DNS load balancing perspective, we support DNS load balancing for front-end pools, edge pools, director pools, and standalone mediation server pools. If you've still got a requirement to break out mediation because of your voice needs, you may end up doing DNS load balancing for your mediation server pools as well.
Oh, and there's the override internal web service.
Woohoo! Just what he
but
was
no
asking.
Picture.
Just what he was asking for. Override the internal web services pool FQDN in the topology builder, and then you create DNS-A host records to resolve the pool FQDN to all IP addresses of the servers in the pool.
Question comes up: How do federation requests work for link edge pools with the federation routes and DNSLB?
So, if your federated partner supports DNS load balancing for their communication,
which by default is your Lync 2010, Lync 2013
yep,
federator,
then they will resolve multiple records if you are doing DNS load balancing on the outside for your federation record. If they don't, which it's very possible that they don't, especially if you're doing open federation, they're just going to return one of those records that's parsed by their edge server, and if that one is down, they aren't going to try anymore.
Right. So remember, federation, assuming you're open or doing a DNS lookup for federation, then you are doing a query for SIP federation TLS underscore TCP. That's an A record name. So let's say that's sip.contoso.com. When we resolve sip.contoso.com, if you're capable of doing DNS load balancing, you're going to pull back however many A records are associated with sip.contoso.com. So you're highly available from the edge, assuming you're talking to a highly available edge, edge to edge. But to your point, if PIC does a request and you're not there because they tried and it's done.
Yep.
Or OCS tries to do it, or XMPP tries to do it, or things of those nature.
Depends on what your requirements are for who you need to communicate with and how highly available that communication needs to be.
Right. You could be just as highly available as anyone else, but if the other side doesn't realize it, you're not highly available.
Yep. So when you're designing a hardware load balancing based solution, really, again, what we were talking about previously was even if you implement Lync 2013 with a hardware load balancer, the hardware load balancer will be in the mix. I will request from DNS to talk to, hey, what's the resolution of pool.8atom.com? It will resolve to the VIP on the hardware load balancer. I will then talk through that hardware load balancer to one of these servers.
One he decides, because that's what the load balancer
whichever one
decides.
he decides I should talk to, whether it's least connections or round robin or whatever it's doing. Then, in fact, my server will very possibly override that decision and send me somewhere else.
Yeah, almost positively will in a large pool.
Yeah.
In a 3 server, who knows? You can get lucky, but all he's doing is making that initial connection for you, and then.
Yep. He makes that initial. This load balancer makes that initial connection, and then you may drop it and go directly to the front end that is preferred to service your requests.
Right. And again, that's from a SIP perspective. Obviously, web traffic is doing it just like it would before. It's a web services do its thing.
Right. It doesn't do a redirect.
Right.
But even when you're implementing DNS or hardware load balancers, you'll notice these front ends are still in DNS. They still have A records that show up in DNS. It's just that pool.8atom.com record resolves to the hardware load balancer.
Right, only one record into the HLB.
Yep. So
Must be a hardware load balancer to be a hardware load balancer. That's an awesome line. Prerequisite for a hardware load balancer must be a hardware load balancer.
But I thought Kemp sold some virtuals.
There are virtuals, as does F5, but they're still load balancers. And they still call them HLBs.
Right.
Well, anyway.
It must expose a VIP address through ARP, ARP being Address Resolution Protocol.
Oh.
It must allow for multiple ports to be opened at the same time. So that hardware load balancer can't be a one-to-one relationship between ports and IP addresses. It must be able to do that. And it must be able to provide TCP level affinity, that is source address affinity. We used to have a requirement there that for mobility scenarios, that hardware load balancer needed to have cookie
persistence with a specific cookie name. It was very specific.
Very specific and unique. I like that we've gotten that back down to TCP level affinity.
Yeah, much easier to support and implement because everybody supports it. So.
Yep. From an infrastructure point of view, the VIP must have a single DNS entry, as we've talked about before. And the VIP must be a static address. It can't be a dynamic DNS record of some sort. Every Lync servers have to have their DNS record registered in DNS.
Right, and that's the same hardware or DNS load balancer, right? That's we need to talk to the server. That's MTLS. So.
Yep. And then the network adapter must have exactly one IP address. That is, in this case, you shouldn't be multi-homing your Lync front end.
Right.
And really the only scenario we support for multi-homing Lync front ends is in a mediation server. We support a mediation server to be multi-homed outside of Edge, right? But we support a mediation server to have one connection that's on the public side and one connection that's directly to a gateway on a private LAN. So when we're talking about designing our services for load balancing, what we really need to think about is our scaling requirements, our organizational requirements, the number of users in any given site, and whatever we've decided as our requirement for high availability and resiliency. And this is just another reminder for you that all 4 of these roles in a Lync Server 2013 environment do support DNS load balancing.
That's right. And if you look at the 4 roles that are there, all but the enterprise or the EE role support just 2 to be considered a DNS load balance pool that's fully supported. So 2 edge servers, 2 directors, 2 mediation, you have an HLB or a DNS LB pool or HLB pool capable, recommended highly, strongly, wordedly.
To be 3?
3 for enterprise.
Yeah.
But otherwise, the two servers gives you that HA world.
Yeah. And what we should note is, in a migration scenario where you're coming from a prior version of the product, be it OCS R2, not Lync, but in an OCS R2 migration, you may be in a case where you've still got hardware load balancers in front of those pools. We would still highly recommend, and though it may be a little more work to get the DNS load balancing set up on the front end, you'll want to get DNS load balancing set up for your Lync 2013 pool.
Yeah, the complexity level is, there's no comparison, first off. And when we get into it, we've specifically had customers that have had HLB, what looked like to be deployed correctly, and coming from an OCS world, so retained in the 2010 world and now the 2013 world, and it wasn't until we finally were brought in and looked at it and said, why are we doing HLB still? Because it was there, ripped it out, DNSLB, everything's fixed. So something wasn't right. Rather than spend the effort and time and with 0 net gain by having the HLB in their environment for what they had it for, that's what we did. Again, we're not getting rid of the load balancers. We still need them. So the investment isn't lost. We have to have it for web services for HA. You have to. So they're still going to be in play. They just won't be as much in play. So they can do more now. So now you've freed them up to go play on other websites and exchange and all kinds of fun stuff. So it's a good thing. Yes.
And in terms of thinking about this, should I weigh my scaling requirements over my organizational requirements and my number of users in a site to decide, do I do hardware load balancing or DNS? And the truth is, no. It's really a personal judgment that you have to make about, do I feel comfortable enough to deploy DNS load balancing? Am I comfortable with the way my clients are going to behave and that I've got clients out there? Or am I more that I've got a really hard and firm grasp on my hardware load balancer and it works and I know it works and I'm ready to support it and continue using it?
Yeah. So here's one for us. And actually, this has been questioned a couple times. And actually, I think Premier Sports changed their stance at least once. And the question is, can I do DNS load balancing on the inside interface of my edge and hardware load balancing on the external side of my edge?
Yeah, and I don't know what the current TechNet says.
I believe the current standing still is it's not supported. Does it work? Should. And at one point, we've had certain things where PSS has come back and said to do it that way. And you guys know who you are if you're listening. And so it was supported because I got it written for that client. And it worked just 100% fine. But as the general masses know, it's not supported. Now, the good news is hardware load balancing edge servers is the simplest of hardware load balancing. Getting into the front ends, it can get really messy. But it's not that difficult. It does take time and planning and effort and everything else that goes along with it. And there's an extreme cost of IPs, like we've stated,
completely agreed,
on the outside. So as long as you're willing to live with all of that.
And to clarify that, one thing I would probably make sure we know is when we say hardware load balancing the edge, we're really talking about hardware load balancing the access side of the edge, not the AV media.
That's right. That's right.
So in terms of guidelines for deploying DNS load balancing for a front-end pool, you can ask yourself some of these questions and they'll tell you, should you deploy DNS load balancing or must you deploy hardware load balancing, or is that the recommendation? And the questions really get to, are my clients homed on 2010 and 2013? Are my users running old clients? Do I need to interoperate with older servers? Or am I only interoperating with newer servers? What version of Exchange UM am I using?
It's funny, because you look at the very first question, are all or most running? The recommendation is if most, your impact is minimal. I guess it can't be stressed enough how highly recommended it is to do DNS load balancing whenever possible.
Get there as quickly as you can.
Do it. If 90%, I would say 90 or even maybe 80% of your users are capable of DNSLB, so they're 2010, 2013 clients, it may very well be worth the risk of just doing DNSLB and not going through the
until you
cost
can
and
migrate
effort
the
and
rest of the people.
the testing effort, the support effort,
Yep.
yeah. So you really only want to do HLB if you really require it, and the requirements are driven off this slide, and it shows you what it is. So if you're an older version of Exchange, that's what's going to be. The 2010 SP1, I think it
Yep.
was. Since then on up, we supported
Yep, SP1.
DNSLB. 2013 natively, that's just how it works. So it's not. It should not be a large challenge for those that have completed their migration, or are 2010 to 2013. It's a non-brainer. So
Most definitely. So we're back to this slide. Do you have a question coming in?
no, I was just laughing at the slide.
Yeah, we're back to this
Coexistence
slide where
again.
it's talking about
Aw.
coexistence, which is when you're designing a coexistence strategy and you want to really think about what it takes to migrate from these older clients onto the newer clients, from that older server onto the newer server, we know that if we have a back end here, we may have an old pool here.
Old.
Right? We may have an old pool. That old pool over there that these old clients used to be signing into that had a hardware load balancer that was pointed at it. Once you get to a critical mass of users who've been upgraded down here to that newer client, I might get rid of this. I might get rid of that VIP that's on here and just let people resolve the multiple A records. So,
Yeah, it's really, I guess it can't be stressed enough, but you're better off being DNS load balance, which also means you're better off being a Lync 2010, 2013 client. And then we're talking 2013 as a whole thing here. So we would say the 2013 client, and really the exception and the need for 2010 is Windows XP. So if that's sad.
and the users are going to be in a little bit of a limited functionality state in that. So
yeah. So it's not what we want. But okay.
sorry, one sec. Sorry about that.
Wrong button again.
I know.
I know.
And we were just finishing the
It
session.
was the last slide. Awesome.
It was the last slide and I had to pop through it. So if there are no more questions, I think we're going to call high availability here and come back in and do disaster recovery in a couple of minutes.
Well, we have a couple that just came in.
Let's go through them.
Okay. Do I have to set the default route to HLB, and do I have to add static routes to internal networks on the edge servers?
So if you're deploying hardware load balancers in your environment, both internally and externally, there are definitely requirements, and the F5 documentation or the KEMP documentation will walk you through what the requirement is for the routes. Yes, it is the case that you will still use the default gateway will exist on the outside interface of your edge, and on the internal interface of your edge, you'll have a default route or a static route
to get back to the inside.
Back to the inside, but that static route doesn't actually have to transit through the hardware load balancer to get there.
That's right. At that point, it's whatever your networking route happens to be, and we're agnostic. We don't know.
We don't
care.
have to default the gateway. As far as I've seen the documentation, we don't have to default the gateway on the inside to the interface of the hardware load balancer.
Okay. Our next one, on the multi-home supportability you mentioned, does this mean you cannot have front ends and most any pool servers inside the network to use multiple NICs on several different network segments?
Correct. Yeah, that is the case, right?
I mean, it's not designed by any means, because we'll have asynchronous routing and things coming in one NIC, out another NIC, things that it's not designed. Even if you did your networking correctly, it's not by design how it works.
Agreed, but Lync does have a provision to make the Lync services only listen on one of those IPs, and it will reply only on one of those IPs on one of those NICs. But you're getting into a little bit of a complex scenario in there. I believe there is a supportability statement that we could find about multiple NICs in front ends, but it's not really recommended. But if you've got multiple private NICs for management or something, you're going to have to do more work in your Lync servers to configure that so that those NICs don't listen for Lync traffic.
Yeah, minimally, you're going to have to go flip the switch. Like if you had, in fact, we had to do it in some of the master stuff where we had to configure the server to say listen only on, and then even though it was only one IP we needed, we had to add it twice, both for mediation and for the SIP services.
Yep.
Otherwise, it was listening on all kinds of IPs, and that's very. And complexity is where we get into things. You really need to figure out, is it worth the effort, of what is it you're trying to accomplish here, and is it worth what you're trying to do?
But yeah, we'll try and find a supportability statement for you about what support we have for multiple NICs on different subnets for front end servers.
Okay, the question about hardware load balancers, are they needed like F5? So I don't know if you can wait to the question to the party, but yes,
we technically
HA,
still need some sort of hardware load balancer solution to provide high availability for your web services.
Now, can you do a poor man's HA by doing a DNS manual change?
If you're doing that, I'd rather you implement IIS ARR.
And use the free and just use it, right?
Use the free solution IIS ARR. On the Nextop blog, a really good article actually, was posted about using IIS ARR modules. So the application rewrite and rerouting rule, I think. It's a set of IIS modules that can do poor man's DNS or poor man's hardware load balancer through IIS. And there was a really good article posted on Nextop about how to do that.
Okay.
With that, I think we're going to close it here, and we'll come back with disaster recovery with Brian in a few minutes.
That's right, and tie right into what we're going with. So thank you all, and we'll see you soon.